Do you know what exactly is deep learning? Do you know what is the difference between machine learning and deep learning? Welcome to our channel where we explore the fascinating world of artificial intelligence, technology, and a lot more. So, before starting this video, please like this video and subscribe to our channel for future updates. Machine learning and deep learning are two subfields of AI that are revolutionizing the way we process and analyze data. What is machine learning? In the field of machine learning, algorithms are created and that can recognize patterns in data and make predictions or judgments without being explicitly programmed. Since algorithms are built to get better over time as they process more data, they are referred to as learning algorithms. The basic objective of machine learning is to create models that can make precise predictions or judgments while generalizing well to new, unexplored data. This is accomplished by giving the algorithm a sizable data set that contains illustrations of the predicted inputs and results. The algorithm then looks for patterns and relationships in the data to try to learn a function that converts inputs to outputs. There are several types of machine learning algorithms, including supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is the most common type and involves training the algorithm on labeled data where the input and output pairs are provided to the algorithm. This allows the algorithm to learn the relationship between the input and output and make predictions on new, unseen data. Unsupervised learning, on the other hand, involves training the algorithm on unlabeled data where the input data is provided but the expected output is not. The algorithm then tries to learn patterns and relationships in the data without any guidance, which can be useful for tasks such as clustering or anomaly detection. Using reinforcement learning, an algorithm can be taught to base decisions on rewards or punishments. The algorithm picks up new skills by interacting with its surroundings and getting feedback from it in the form of rewards or punishments for its activities. Healthcare, finance, marketing, and robotics are just a few of the sectors and businesses where machine learning has a wide range of applications. Machine learning is utilized in the healthcare industry for activities including disease detection, drug discovery, and individualized care. Machine learning is used in finance for trading algorithms, risk analysis, and fraud detection. Machine learning is used in marketing for systems that segment customers, target advertisements, and make recommendations. Robotics uses machine learning for manipulating, navigating, and object recognition. Effective machine learning algorithms need a lot of data, which can be difficult in particular situations. The algorithms will learn patterns and relationships from the data they are trained on, and if the data is skewed, the algorithm will also learn those biases. Data quality and bias can also be problems. The whole, machine learning is an effective tool for getting predictions or making decisions in a variety of applications. As technology and data continues to progress, machine learning will undoubtedly become even more prevalent and impactful in the years to come. What is deep learning? A particular field of artificial intelligence called deep learning focuses on teaching neural networks to learn from massive quantities of data and generate more sophisticated predictions. It has transformed AI and is utilized in many different applications such as speech recognition, image recognition, and natural language processing. Deep learning's fundamental premise is that artificial neural networks can learn from data. These networks are made up of layers of linked neurons that have been taught to spot patterns in the input data. Each neuron in a layer accepts input from the neurons in the previous layer and creates an output that is transmitted to the neurons in the following layer. The prediction delivered by the neural network is the output of the last layer. The strength of deep learning resides in its capacity to learn representations of the input data that are useful for making predictions. The neural network automatically picks up these representations, sometimes referred to as features, while it is being trained. As a result, difficult issues can be solved using deep learning models without the requirement of explicit feature engineering. Deep learning has had a considerable impact on computer vision, with convolutional neural networks proving particularly successful at tasks such as picture categorization, object recognition, and segmentation. Convolutions are performed on the input data by layers that make up CNNs, enabling them to learn features that are invariant to translation, rotation, and scaling. Another area where deep learning has been successful is natural language processing, where recurrent neural networks and their derivatives, such as long short term memory networks, are extensively utilized. RNNs are designed to process sequential data such as text or speech and are particularly good at tasks such as language translation, speech recognition, and text production. The success of deep learning is due in part to the availability of large data sets and powerful hardware such as graphics processing units that can perform the necessary computations in a reasonable amount of time. In addition, there have been significant advances in the development of optimization algorithms such as stochastic gradient descent and its variants that are used to train deep learning models. One of the challenges of deep learning is the risk of overfitting, where the model becomes too complex and begins to memorize the training data instead of generalizing to new data. Regularization techniques such as dropout and weight decay are commonly used to prevent overlifting. Another, another challenge is the interpretability of deep learning models, which can be difficult to understand due to their complex structure and large number of parameters. There has been significant research in developing methods for interpreting deep learning models, such as visualization techniques and attribution methods, that can highlight the parts of the input data that are most important for the prediction. While there are still challenges to be addressed, deep learning has already made significant contributions to the development of intelligent systems and will continue to be an important area of research in the years to come. That's it for today. We hope you found our video interesting. Please give it a big thumbs up and share it with others. Also, if you have not already, please consider subscribing to our channel and don't forget to turn on the notification bell so you don't miss out any of the new uploads. And thanks for watching and see you next time.